Hello, my friends. So we are back, and then this is actually the end of our fourth week. Because tomorrow, remember, is Good Friday, so there's not going to be a lesson. It's cool. So we're going to finish out our week. All week we've been talking. It's actually the ninth. It's not the eighth. Sorry. We're going to be talking all week. We've been talking about linear functions, and we're going to finish off the week by talking about comparing them, meaning looking at two things and comparing their slopes and y-intercepts. Okay, so I want you guys to think about this here. We've actually talked about something similar to this before, if you guys remember, with the plant growing contest. So the city's second best scientist knew that his robot was too slow to beat the red robot in a 100-yard race, so he rigged the race to make it end with a tie. What do you think the scientist did, and how much faster than blue robot does the red robot run? So how much faster is the red robot, and what might have happened to cause them to have a tie if one was faster than the other? I'm going to let you guys write your thoughts about that, starting right now. Right now that you've read your thoughts about this, I'm hoping that you are writing something along the lines of that they probably pushed the blue robot up 50 feet and they got a head start because the red robot's going 10 yards per second, where the blue robot's only going about 5 yards per second. So they're actually going about twice the speed, even though they ended in a tie, which would make sense then if they started halfway ahead. All right. So yeah, so the blue robot only did half the race. That's not fair. All right, so this kind of thinking about, again, those are two linear functions that we actually just compared. So we already kind of met our goal for the day. All right, let's keep going. This graph, the graphs of two linear functions intersect if they have two different rates of change. So if two lines have a different slope, eventually they're going to hit each other or cross each other. So as you can see here, these two lines intersect here, these two lines intersect here because they have different slopes. Two lines that have the same slope are never going to intersect. If two lines have the same slope, that's going to mean that they're parallel because they're changing at the same rate, which we're going to see soon. Okay, so for each city, there's a linear function that describes the temperature in degrees Fahrenheit in terms of the number of hours since 8 a.m. Which function has the greatest rate of change? So let's look at Eastbury. 8 a.m., the temperature was 62 degrees. And then between 8 a.m. and noon, the temperature increased 3 degrees per hour. So this rate of change is 3 per hour. That's what it's changing by. In Topperville, T equals 54 plus 2H, where T is in degrees Fahrenheit and H is the number of hours since 8 a.m. So that means it was 54 degrees to start, and then it was adding 2 per hour. So far, Eastbury has the greater rate of change. All right, we're not going to look at 6 and 7 a.m. because we know that we're only looking past 8 a.m. So from 8 a.m. to 9 a.m., it went from 62 to 64, so that's also 2 degrees per hour. So which has the greatest rate of change? That would be Eastbury because they're changing 3 degrees per hour. The other two are only changing 2 degrees per hour. All right, let's keep going. All right, the functions below describe the temperatures in degrees on the same day in two different locations. Which has the greater rate of change? What does that mean? So, at 4 p.m., the temperature is 70 degrees. Between 4 p.m. and 10 p.m., this decreased 2 degrees per hour. So, it's just going down 2 per hour. Oh, yeah, let me check something here. Oh, yeah, no, those are all increasing. Okay. 2 degrees per hour. So this would have a rate of change of -2 because it says decreasing 2 per hour. And if you look here, this does 2. This has starting at 72, and it's also decreasing 2 per hour. So this would mean that those two lines would have the same slope. One starting a little bit higher, this one starting at 72, this one starting at 70, but they have the same slope. And if you guys remember from what I said earlier, that means if we graph these two temperature changes, we would actually get parallel lines because they have the same slope. If they have the same slope, they have parallel lines. All right. If you graph these three functions on the same axes, what would be true about the lines that represent Eastbury and Hilltown. So Eastbury and Hilltown, and one has a change of 3, one has a change of 2. So those lines would intersect at some point or cross at some point because they are not parallel. They don't have the same slope. What would be about Hilltown and Topperville? Those both have a rate of change of 2, so those would be parallel lines because they have the same slope or rate of change. They're both changing at the same amount. Again, parallel lines have the same slope. Okay. There's a linear function that describes the temperature. So compare the initial values. So we just were comparing slopes, and now we're going to compare initial values. All right, so at 8 a.m., the temperature was 62 degrees, so that's our starting point here, or our initial value. Here, we're starting at 54, so that's our initial value. And here, remember, so it's saying starting at 8 a.m., so here at 8 a.m., we're starting at 62 degrees. So what do these initial values mean? That means it was actually, so Eastbury and Hilltown started at the same temperature. They both started at 62. Topperville started a little bit cooler at 64. So that's that. All right, again, so we're comparing these 3 different functions by their initial values and by their slopes. Let's keep going. Okay. These functions describe temperatures on the same day. Compare the initial values. What can you conclude? At 4 p.m., the temperature was 70 degrees here. And then this says in the number of hours since 4 p.m. So at 4 p.m. it was 72. And then it was decreasing 2 per hour. And we already said before that these would have the same slope because they're both decreasing 2 per hour. But this means that it's always going to be warmer in Schuster. It's always going to be just a little bit warmer because they have the same slope. But Schuster's always going to be a little bit higher of a temperature because even if they're decreasing at the same rate. So that one's always going to be warmer because it had a head start of 2 degrees. All right, so that's the end for today. So now you're going to head to the Pearson and you're going to complete that, and then you'll be done with 4 weeks of distance learning work, and you're going to enjoy a nice long weekend and hopefully Easter with your family if you celebrate. And I will see you guys back on Monday for the start of quarter 4, which is crazy. All right, bye.